Let's work now on the do now. The instruction says graph the following functions using your calculator and then identify the graph as linear, quadratic, absolute value, and exponential function. So let's now graph the first one. So let's enter that in the calculator. So we have 5x squared, 5x squared minus 2x plus 3. Then press graph. Okay, since the graph here is a U-shape, so we call this one as a quadratic function. So this one is a quadratic function. And you're simply asked to sketch the graph here. So just would like you to look at the calculator, how it looks like, and just make a sketch. So it looks like we have a U shape here. So this is the graph of a quadratic function. For number 2, so we have, let's enter again in the calculator. So we have 6x minus 7 and press graph. Now, since the graph is a straight line, we call this one as a linear function. This one is a linear function. And sketch the graph again. So it looks like it's passing in the y-axis and the x-axis. This one will be the graph. For number 3, so since we have an absolute value here, so I would just say that this one is an absolute value function. So absolute value function. And let's sketch the graph. So enter again in the calculator. So we have absolute value, you press math, then go to num, then press enter. And you see the absolute value symbol. So we have now x minus 3, then go out from the absolute value, then you just press graph. And you have a V shape here. So again, we'll just sketch. So we have a V shape. So that's the graph of the third equation. Number 4, so we have here y equals. So we have 2, and this one is exponent x. Then press graph. So we have, the graph is a half curve, so we call this one as an exponential function. We have exponential function. So the sketch here. Now in the calculator, it looks like that the graph is crossing the x-axis, but it's actually not. So when you try to make a sketch, so make sure that it's actually not touching the x-axis, but it's actually a half curve, getting closer and closer to the x-axis, but it will never cross the x-axis. And that is a very important characteristic of an exponential function. And number 5, so we have here, let's enter that again. So you have y equals 1/2 to the exponent x. So we have parentheses. Now here, I encourage you to learn how to enter a fraction, not just using the division button key, but I would like you to learn how to enter a fraction like in a Microsoft Word document. You enter a fraction. To enter a fraction, you press alpha, y equals. The first one is actually a fraction, so just press enter, and now it shows the fraction symbol. So you have 1 divide 2, so you have 1, go down, 2, then go out, then parenthesis. And exponent x, so this is our exponent symbol, then we have x. And go out and press graph. Okay, still a half curve, so we still call this one as an exponential function because it is actually a half curve. exponential function. And let's make a sketch. So again, if this is my x-axis, it looks like it's crossing the x, but it's actually not. It's just get closer and closer, but it will never intersect the x-axis. And that is a very important characteristics of an exponential function. So this time, let's answer now the think, write, and share one. The first question says, what is the difference on the graphs of number 4 and number 5? So we are actually looking at this time just number 4 and number 5. And the keyword here is looking at difference on the graphs. So I would say that the first graph, so when I trace this one from left to right, if I'm following here, this one is an increasing function. And if I trace this one, this is actually a decreasing graph. So I would now describe the difference between the graphs of number 4 and number 5. I would say number 4 is an increasing graph, while number 5 is a decreasing graph. Okay. So that would be the difference in terms of looking at the graphs. The second question is asking, what is the difference of the equation of number 4 and number 5? So this time you are looking at the equation this time. So looking at the equation here, what is the difference? So looking at these two equations here, I would say the difference is just the number here, 2 and 1/2. So I would say number 4 has a whole number base, while number 5 has a fraction base. Now, number 3 is asking now, what do you think are the numbers that makes it an increasing graph or a decreasing graph? Okay, so let's now look at number 4. Number 4 is an increasing graph, and number 5 is a decreasing graph. Now, from question number 2, we observe that the difference there is a whole number and the other one is a fraction. So let's now observe what are really the numbers that makes it an increasing graph or a decreasing graph. So let's start like looking at investigating. Suppose I put, shall we say, 1, 2, or 3. Okay, so let's say 1.5. Suppose I put 1.5x, whether it's still decreasing or increasing. We have y is 1.5 exponent x and graph. Okay, so this one is still increasing. So I would say, okay, this one works, 1.5. What about if I put actually here 2.5? Suppose you have y equals 2.5 to the exponent x. So I would like to test because not just whole numbers, but also decimals or fractions actually. So shall we try 2.5? So you have 2.5 and press graph. Still in increasing function. What if I put y? So this one is still increasing. What if I put y plus 1 to the exponent x? Let's try that one. So we have 1 exponent x and graph. Oh, so this time we graph a line. Now, which means it's not anymore an exponential function. So I would say when when the base is equal to 1, it can never be an exponential function. I put an x here. That means this is not an exponential function. So let's now investigate if I put now zero point 0.9. So you have zero point 0.9. Now y equals, we have zero point 0.9 exponent x. So this one now is less than 1. So I would like to verify whether it is increasing or decreasing. So there's a graph. Okay. It looks to me that the graph is decreasing. So it's actually here. It's decreasing here when you have zero point 0.9. So you have zero point 0.9 raised to the exponent x. What if I have 1.1? We have 1.1, 1.1 exponent x. Let's graph. Okay, it looks to me still an increasing graph, so this is okay here. So you have y equals 1.1 to the x is still fine. What if I put 0.5, 0.6, because 1/2 is 0.5, so I would like to have 0.6. So you have here 0.6, it could be 0.66, or just 0.6. Exponent x graph. Okay, it is a decreasing graph. So actually this one is also, you have y equals 0.6. So the exponent x is decreasing. This is also decreasing. I think we have enough numbers to be able to observe and say that the graph of a function is increasing or decreasing for some numbers. So I would say that the boundary here is actually at 1, because if it's more than 1, it becomes increasing. If it's less than 1, it becomes a decreasing function. So I would say it is increasing when it is increasing when the base is greater than 1, and it is decreasing when the base is less than 1, and I would say greater than 0, because you cannot have also negatives also. So it's between 0 and 1. So this time, let us now make an inference. What do you think is the general form of an exponential function? Now, for you to say it's an exponential function, the exponent of the equation must be a variable. So I cannot generalize this as y equals a raised to the exponent x. So that will be our general form, a simple form of an exponential function. And the second one, when can you say you have an increasing exponential function or a decreasing exponential function? We actually answered that in number 3. I just would like to generalize this. So using now this one as our base, because it depends on the base of the function. So I would say increasing. I will just write it in symbol. Increasing if a is greater than 1. And when can you say it is decreasing? If a is less than 1 and also greater than 0. Or simply saying that it should be between 0 and 1. Okay, so I hope you understand this one, the do now.